Okay, continuing with the 3-2 proofs. For whatever reason, I skipped 22 on the last video, so I will include it on this video with the proofs from the end. So if I'm given that angle 1 and angle 2, no, angle 1 and angle 6 are equal, and BC and EC are equal, I'm going to mark my pictures. 1 and 6, BC and EC. Take our time to write our given because we always want to be able to see everything in our list. Now this is a variation of the butterfly picture, but I do have vertical angles, and so I'm going to go ahead and take them because I always look for them if I have them. And so angle 3 is equal to angle 4, and that is by the vertical angle theorem. Now at this point, I have an angle and a side, and if I'm trying to prove triangles congruent, I'm either going to look for another angle or another side. Well, in this case, I see those number angles. I'm going to investigate to see if I can get 2 and 5 equal. What I do know is that I have a linear pair on both sides. And so I'm going to go ahead and write my linear pair equations. So that is that angle 1 plus angle 2 equals 180. And that angle 5 plus angle 6 is equal to 180. And that's the linear pair theorem. This is our common pattern that we like to see. If they're both equal to 180, we know these two pieces are equal. So by substitution, we can write angle 1 plus angle 2 is equal to angle 5 plus angle 6, and that is substitution. Now earlier, and this is why we like to put our given into our list, I know that 1 and 6 are the same, so I'm going to replace that angle 1 with angle 6 by substitution. And what I've created at this point is I have an angle 6 on both sides, so I'm going to go ahead and subtract that. And so now I can go ahead and say that angle 2 on my picture is equal to angle 5, and my triangles are congruent by angle, side, angle. So triangle ABC is congruent to triangle DEC by angle, side, angle. And as a nice reminder, it's not required, but it's nice when you get down to the end, if you want to say there's step 2, step 1, and step 6 are what's needed to give me my 3 pieces. It's a nice little way to check your answers to make sure you do have the 3 pieces that you need in order to say 2 triangles are congruent. Now I'm going to go ahead and jump to 26 because the other ones are on the other video. And 26 is going to give me my parallel line piece. And as soon as I know parallel lines, I need to start thinking about my angles. In butterfly proofs, like I have, I need to be really looking for alternate interior angles. I'm going to go ahead and I'm going to take my highlighter and I'm going to extend my parallel lines because that makes it a lot easier to see. Okay, mark my picture. These guys are parallel. Now C being the midpoint gives me equal pieces. Now be careful. It's the midpoint of BE. I know nothing about AD. Temptation is to say that AC equals CD also, but I don't know that. I only know that BC equals CE. I should say EC, excuse me, by definition of midpoint. Now there are actually 3 ways to prove this proof. I can prove it by angle, side, angle, and I can prove it 2 different ways by angle, angle, side. I'm going to go ahead and use angle, side, angle, but if you check the key, I made the notes about how to do it the other ways. This is my butterfly picture, so I know I have vertical angles, so I'm going to write those down. So I have angle BCA is congruent to angle ECD by the vertical angle theorem. Now I'm going to use those parallel lines, and I'm going to use BC as my transversal, and what I have then are alternate interior angles. And so I know that angle B is equal to angle E because parallel implies alternate interior angles are equal. From there, I have enough information, and I say that triangle ABC is congruent to triangle DEC by angle, side, angle. Now, if you're curious about the other methods, you can use AD as your transversal, and then angle A and angle D are also equal by alternate interior angles. So you can use the 2 alternate interior angles for angle, angle, side, or you can use the vertical angle and this alternate interior angle for angle, angle, side, or how we did it with angle, side, angle. They are all correct. Another key point, these 3 steps can be given in any order. They don't have to be in this order. You just have to do steps 2, 3, and 4 before you can say step 5. On to 27. Now, median is an old definition. That's from Unit 2. And the definition of median of a triangle, and this is a typo, I apologize. XZ is the median of triangle XYW, and XW equals YX. That's the given. The definition of median is that it intersects in the midpoint of that side. And so I'm going to go ahead and say that WZ is equal to YZ by definition of median. Now the other piece of given that they give me is this side here and this side here. Now that I have 2 sides congruent, I'm either going to look for side, angle, side, which I can get with the isosceles triangle theorem, or 2 sides, I'm going to look for side, 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 which I also have with the vertical angles, or with the reflexive side, excuse me. So I'm going to go with the reflexive side, because I always use that if I have it. So XZ equals XZ by reflexive. And my triangles are congruent. Triangle WXZ is congruent to triangle YXZ. This is a fold in half congruency, so it matches up. That is by side, side, side. W and Y are corresponding parts of congruent triangles are congruent. Now that was the long way to this proof. Now that I'm all done, I just now realized what we were trying to prove are the base angles of the triangle. And so right here, I could have said that angle W equals angle Y by the isosceles triangle theorem and been done. But just in case you needed to know how the triangles were proven congruent to prove other pieces by CPCTC, you can now see that that is how it works. Next proof. Now this proof initially looks difficult because you have to look at the big triangle first as being equilateral. And then we are going to move inside and look at this triangle and this triangle. And the key is going to be where those two lines overlap and change color. So, given triangle DEF is equilateral, DG equals FG. DG and FG. Now, it being equilateral gives me three equal sides. So DE equals EF, which equals DF by definition of equilateral. And once I mark those, you can clearly see those colored triangles. If I use that reflexive side, EG is equal to EG, I now have my two triangles. Congruent by side, side.